Demand for high-speed railway networks is rapidly growing as a new era approaches and more maintenance and services for the track infrastructure are required. Continuously welded rails for tracks are now an essential element to obtain rapid, safe and comfortable railways. HAKUSAN Manufacturing Company Limited has been helping in the development of continuously welded rails by promoting our reliable and high technologies. At present, there are many kinds of welding methods, such as enclosed arc welding, aluminothermic welding and flash butt welding. Each welding method has its own characteristics. For example, enclosed arc welding requires higher skill and longer welding time. The method is not now used often for rail welding. Aluminothermic welding is extensively used due to low equipment cost, but the technology contains some problems in welding strength. Flash butt welding is reliable both in terms of strength and working time. However, it requires large equipment costs and big electric supply equipment with high capacity. It is not suitable for site welding. This is a big disadvantage. In the technology of HAKUSAN's gas pressure welding, rails are welded by using oxy-acetylene flame and the pressure is applied to the welded joint. Gas pressure welding is as capable as flash butt welding in strength and requires much less investment for its equipment than flash butt welding. Because of its outstanding mobility, gas pressure welding is the most suitable welding method for top welding as well as site welding. Now let us introduce the gas pressure welding of HAKUSAN Manufacturing Company Limited. It has drawn considerable attention in terms of its capability and prospects for the future. Continuously welded rail by gas pressure welding has been adopted not only by railways in Japan but in many other countries, where they have started track laying by using our technology. In Japan, our gas pressure welding has been applied in more than 90% of rail welds on the Shinkansen lines. You can see HAKUSAN's gas pressure welding machine at many track laying sites, such as on local lines of Japan Railways, many private railways and subways. This is because our customers know very well about the outstanding reliability and mobility of our products. The market for HAKUSAN's gas pressure welding machine is expanding on a global scale. Our machines are widely used for track laying in Korea, Taiwan, China, Myanmar, Sri Lanka, Thailand and elsewhere. And the Konkan Railway in India succeeded in reducing welding costs by as much as $1.6 million thanks to the introduction of HAKUSAN's gas pressure welding. HAKUSAN's gas pressure welding demonstrates great advantages in terms of strength, economy and labor saving. Let us give you a brief explanation of our gas pressure welding. We apply a constant pressure of 245 kilograms per square centimeter or more to each sectional area to be welded. At the same time, we heat up the joint section with an oxy-acetylene flame so as not to melt the joint where we are forming a bulge. This is an enlarged schematic of the welded face. The contact condition is local at first, but the area of metallic contact is rapidly enlarged by pressure and heat. Crystals across the welded face are generated around 800 degrees Celsius, and the two rails are metallically welded to each other. Then trimming is carried out. The bulge at the gas pressure welded joint in the red-hot condition is removed by shearing. Welding performance is evaluated by the surface condition at the joint after trimming the bulge. The welded part in this way is stronger than a rail welded by other methods such as enclosed arc welding and aluminothermic welding. The chart here shows a comparison of bending strength, deflection, fatigue strength and tensile strength with those of other methods using 50 kilogram rail. I'm sure you'll understand that welding across dissimilar materials, such as in enclosed arc welding and aluminothermic welding, involves problems of strength. Flash butt welding and gas pressure welding are very different in terms of place of execution, equipment cost and so on, although they have almost the same performance. Now we'll show you the process of gas pressure welding again. This is excellent in both performance and economy. We align a piece of rail to a rail end grinder and machine the end surface until we get a flat surface which is perpendicular to the longitudinal axis of the rail. This is how to adjust gas pressure. We first set the flow rate of oxygen gas by adjusting the pressure. The pressure of the acetylene gas is set to adjust the flow rate. After the adjustment of the gases, we're going to set the hydraulic pressure. First, we set the clamping force and the trimming force. Second, we set the pressure welding force. Clean the end faces of both rails after each face is finished by grinding machines with cleaning liquid to completely remove impurities such as oil, dirt and iron powder. Then we butt both end faces. Set the gas pressure welding machine, clamp the rails to set the prescribed pressure welding amount, and then start pressurization. After setting the trimmer on the rail, the burner is set. Ignite the gas with the burner away from the end faces. Make an adjustment so that the flame of the right burner is uniform with that of the left burner. Continue heating and perform pressure welding while the burner is moving along the pressure welding gauge. Perform buckling at 10 mm before the prescribed pressure welding gauge. Atoms of two rails at the contact face are mixed through the pressure and heat. Crystals are generated at the bulge where metallic bonding is achieved. After checking that the gauge reaches the prescribed welding line, the upset part needs to be immediately trimmed to get smooth rail surface. You want to shear the bulge while the rail is red hot. Remove the gas pressure welding machine and measure straightness and bend. Bends must be corrected vertically and laterally if necessary. This is important for quality assurance. After cooling, finish the rail surface with a grinder. If you weld heat-treated rail, you need post-heat treatment. Gas pressure welding work is completed with the final inspection by a penetrant test or a magnetic particle test. We confirm the performance and capability of the gas pressure welding machine using a bending test machine. Gas pressure welding has been contributing to the safety and comfort aspects of railways as well as cost saving. How do we produce the gas pressure welding machine? We'll now show you the production system of the welding machine. We see a variety of needs for track laying under various operating environments and conditions. We designed by CAD to respond to these many types of requirements. Then we machine by lathe and wire cut electric discharge machine. The parts produced here are assembled under strict inspection using three-dimensional measuring instruments. Our gas pressure welding machine comprises body, hydraulic device, gas device, face grinding device, bend correcting machine, and grinders for finishing. HAKUSAN's gas pressure welding machines are supplied to all parts of the world. They demonstrate our outstanding technological standards. The highest quality supported by established technologies creates the strong global demand for this machine, which exhibits excellent strength, workability and economy, and is used in 8 countries around the world. It is now the standard welding machine for installing continuously welded rails. The gas pressure welding machine joints not only rails, it unites the world on tracks that extend into the future.